All right, hey everyone, welcome back for some more um, logistic regression introductory stuffs. And so now we're going to talk a little bit about interpreting the slope coefficient. And so that will actually be what this entire video is about. And so remember for our example with colleges, our estimated slope here is 0.5774. And so I'm just going to go ahead and write that somewhere just so we've got it. And so when we interpreted a slope coefficient in linear regression, we kind of had the standard interpretation. And so now that we're modeling on this log odd scale, the interpretation isn't really going to go quite as smoothly. And so let's take a second to talk about why we can't just like reuse this interpretation but for probabilities. And so I'm just going to draw an example of a typical kind of logistic regression curve. And maybe 1, 2, 3, 4. And so we can't like interpret this slope coefficient on this probability scale, because if we did, then we'd say, okay, when x increases from 1 to 2, it looks like the estimated probability is jumping quite a bit. So it's looking like it's going from something really small to something really large. But when x increases from like 3 to 4, the estimated probability barely changes at all. And so because of that, we can't just have this general, okay, for a 1 unit increase in x, here's what we expect to happen to the probability, because it changes depending on where we are on this graph. So we can't just do what we did before. So let's talk about what we can do. And we're going to end up using this form of this logistic regression equation. Remember, we called this the logit form. And this is nice because this is linear on this logit, which all the logit was log odds scale. So because it's linear on this scale, let's see how we can make that work for our interpretation. So if we raise both sides of this equation by, or raise it to the e, if you remember from your like algebra or whatever, that cancels out this log, and so you could end up with the estimated odds as equal to this e to the beta hat 0 plus beta hat 1 x. And so this will just make it a little bit simpler when we go through these calculations of finding the odds. And so let's go ahead and find the odds of a university being public for a student-faculty ratio of 14. And so all I'm doing then is just seeing that the odds is equal to that. And so if you use R to actually find that, you should get an estimated odds of 0.1241. Let's repeat that then for x equals 15. And if you did that, you should get an odds of 0.2211. It's not super clear why we're actually doing this yet, but it will be in a second. And so we can repeat that again for x equals 16. And you should wind up with an estimated odds of 0.3939. Okay, so now we've got these three different odds for x equals 14, 15, and 16. So let's take a couple ratios and let's find the odds ratio first for x equals 16 and x equals 15. And so that odds ratio, I'm going to do the odds that x is 16 divided by the odds that x is 15. Or sorry, that doesn't really make sense. The odds for x equals 16 and the odds for x equals 15. And so if we take that ratio, we should wind up with 1.7814. Let's repeat that process for x equals 15 and x equals 14. So that ratio is 0.2211 divided by 0.1241. If you do that calculation, you should get 1.7814. So, what is going on? So it can't be just like coincidence that those two odds ratios are exactly the same, right? And so let's figure out where or how this relates to our summary table of output, which I've kind of reproduced here just for convenience. And so if you kind of scan for a 1.7814 in this table, I'm not really seeing anything. So just take a second to kind of think about where that 1.7814 might be coming from in our table. Okay, so keep in mind that when we found these odds, we first exponentiated. And so let's see what happens if I just raise or do this e to the 0.5774 calculation. And so if you do that in R, or if you do that on a calculator, that turns out to be this 1.7814. So, I don't know, hopefully your mind is blown a little bit, like why that actually happens. It actually, you could just figure out why it happens just with algebra. And so let's go ahead